Hello viewers, in the previous class we have gone through the properties on medians and few problems. Now in this class we are going to look at more problems on medians. Here two medians AD and BE of triangle ABC intersect at G at right angles. If AD is equals to 9 centimeters and BE is equals to 6 centimeters, then the length of BD is. Here is the figure. Two medians AD and BE intersect at right angles. So here the angle between these two medians is right angle, 90 degrees here. AD is equals to 9 centimeters and their intersection point you call it as a centroid. We all know centroid divide the median in the ratio 2:1. So G divides AD in the ratio 2:1, therefore AG is to GD is equals to 2:1. Always you have to look at from vertex to the side. So AG becomes 6, GD becomes 3. 2:1 ratio, put together it is 9. In the same manner, G divides BE, BG is to GE is also in the ratio 2:1. Now we know BE is equals to 6. 6 you divide in the ratio 2:1, it becomes 4. This is 4, 6, 3 and 2. He is asking you the length of BD. We can clearly see triangle BDG or BGD is right angle triangle. In right angle triangle, hypotenuse is a side which is opposite to right angle. So BD square is equals to side square plus side square. The other two sides are 4 and 3. So 4 square plus 3 square is equals to 16 plus 9 is 25. Length of BD is equals to 5. Suppose if they ask you length of BC, then it is double of BD, which is 5 into 2, 10. Now let's look at the next problem. If the length of three sides of triangle are 6 centimeters, 8 centimeters and 10 centimeters, then the length of median to its greatest side is. If you carefully observe the given sides 6, 8, 10. We all know that 6 square plus 8 square is equals to 10 square. Therefore, these are sides of a right angle triangle. You call it as a triplet. So, these are sides of right angle triangle, right angle at B. 6, 8, 10. Median is a line which divides the opposite side into two equal parts. If you look at the property of a circumcenter, we all know circumcenter in a right angle triangle is a midpoint of hypotenuse. Therefore, if it is a midpoint, you also call this D is a circumcenter. So here I can call D is a circumcenter, and we also know one more property about circumcenter. Circumcenter is always equidistant from all its vertices. Now what are the vertices of a triangle here? A, B, C. So it must be equal distance from A and B and C. Therefore we know AD must be is equals to BD and it must be is equals to DC, which is equals to 5. So always remember, in a right angle triangle, if you want to find out the median drawn on a hypotenuse, median drawn on a hypotenuse in case of a right angle triangle is equals to hypotenuse by 2. Now it's not about all the medians, it's only about the median which is drawn on hypotenuse. The length of three medians of a triangle are 9 centimeters, 12 centimeters, 15 centimeters. The area in square centimeters of the triangle. Median 1 is equals to 9. Median 2 is equals to 12. Median 3 is equals to 15. Three medians are given. We already discussed in the properties of medians. When three medians are given, you just try to find out M, which is M1 plus M2 plus M3 by 2 is equals to 36 by 2 is 18. Then the area is equals to 4 by 3 into under root of M into 18 into 18 minus 9 is 9, 18 minus 12 is 6, 18 minus 15 is 3, which is equals to 4 by 3, 6 into 3 is 18, 18 into 18, 18 square into 9 is 3 square. Overall you get 4 by 3 into 18 into 3. 3 gets cancelled, 4 18s are 72. So here we can apply the formula and do it. The other way around is 9, 12 and 15 are the right, are actually it forms a triplet. So whenever you see three medians, m1 square plus m2 square is equals to m3 square in such a manner. It's actually a multiple of 3, 4, 5. 9, 12, 15 is a multiple of 3, 4, 5. Therefore, it is actually a triplet because 3 into 3 9, 4 into 3 12, 5 into 3 15. So, whenever m1 square plus m2 square is equals to m3 square, this formula changes to 4 by 3 into this whole thing under root of m into m minus m1, m minus m2, m minus m3 is equal to half of m1, m2, because we know for a right angle triangle, if three sides are given s minus a, s minus b, s minus c is equals to half of ab. So, I am applying the same rule here. It is half of m1, m2, where m3 is the larger median. So, you can say 2 by 3 m1 into m2. What is m1 and m2? 9 into 12. Cancel it. 36 2s are 72 centimeters square. So, directly remember the formula 2 by 3 into m1 m2, where your m1 m2 m3 represent the triplets, or else m1 square plus m2 square is equals to m3 square. Let us look at the next one. The three medians AD, BE and CF of triangle ABC intersect at a point G. We know the intersection point of medians is centroid. If the area of triangle ABC is equals to 60 centimeters square, then the area of the quadrilateral BDGF is, let me get the figure. So, here ABC is a triangle and they intersect at the point G. G is called centroid. Now, the shaded region is the area of the quadrilateral he is asking you, BDGF. We know when three medians divide the triangle into 6 equal parts. Actually, it divides, median divide the entire triangle into 6 equal areas. These six triangles which we got are all of them have the equal area. Therefore, there are only two shaded parts. So, I would say area of the quadrilateral, area of BDGF is equals to 2 parts out of 6 parts of area of triangle ABC. So, which is 1 by 3 of area of ABC given as 60, which is equals to 20 centimeters square or square centimeters. So, the answer here is 20 centimeters square. It is actually 1/3 of the entire triangle. Here in this problem, let BE and CF be the two medians of triangle ABC and G be their intersection. We know G is nothing but the centroid. Also, let EF cut AG at O, then AO is to OG. This ratio we have already seen in the property, but once again we will see here. Let us look at this problem. Let BE and CF be the two medians of triangle ABC and G is their intersection. The intersection point of medians is called centroid. Here G is a centroid. Also, let EF cut AG at O, then AO is to OG is. Here is the figure. ABC is a triangle. BE and CF are medians. Their intersection point is G. AG is intersected by EF at O. AD is also a median. We also know AO is to OG is to GD. We proved it by taking AD is equals to 6. If AD is equals to 6, this is 3, this is 1, GD is 2. Therefore, this is 3 is to 1 is to 2. Here only a part of it is asked in the question, that is AO is to OG is equals to 3 is to 1. So, answer is 3 is to 1 in this case. Look at the next one. AD is the median of triangle ABC and O is the centroid such that AO is equals to 10 centimeters and the length of OD is. If O is the centroid, AO is equals to 10 and OD is equals to. We all know centroid divides the median in the ratio 2:1. Therefore, AO divided by OD is equals to 2/1. The given value is AO. AO is given as 10. 10 divided by OD you have to find, which is equals to 2/1. 2 1s are 2 5s are. OD is equals to 5. So, OD is equals to 5 centimeters here. If G is the centroid of triangle ABC, the area of ABC is equals to 48 centimeters square. Then the area of triangle BGC. Let me get the figure for this. Here is the figure. ABC area is given as 48 centimeters square. Then the area of BGC here, AD, BE, CF are three medians and G is a point of intersection of medians, that is centroid. We know three medians divide the triangle into 6 equal parts. Now he is asking you only about one part, that is area of triangle BGD. Area of triangle BGD is equals to 1/6 of the entire triangle ABC. Here ABC is given as 48, therefore 48/6 is equals to 8 centimeters square is the area of BGD. ABC is an isosceles triangle such that AB is equals to AC and angle B is equals to 35 degrees. AD is a median to the base BC, then triangle BAD. So, let's keep this question for a minute and try to understand how median and angular bisector, altitude and perpendicular bisector in an isosceles triangle. Take an isosceles triangle. Here I am drawing an isosceles triangle. Take it as a median. What do we mean by an isosceles triangle? Two sides are equal and their opposite angles are also equal. Therefore, these two are theta and theta. It is also a median because I am drawing a median. If you look at triangle AB, ABD and ADC, okay, two sides are equal, that is AB is equals to AC, BD is equals to DC, and corresponding angle B is equals to angle C here. Angle B is equals to angle C in two sides according to the property SAS. According to the property SAS, we can say these two triangles are not only similar, these are actually congruent triangles. And we all know that congruent triangle corresponding parts are always equal. Corresponding parts means if this is x, therefore this is also x. This 2x is equals to 180 because it forms a linear pair. If 2x is equals to 180, x is equals to 90 degrees. If x is 90 degrees, this AD is also called altitude. And also you look at this angle is equals to this angle because corresponding parts of congruent triangles are equal. If it is phi, this is also phi. Now here AD is also called what? AD is also called angular bisector. If you look at AD is perpendicular to the base and it is bisecting the base. Therefore, AD is also called perpendicular bisector. So, what do you know here? In an isosceles triangle, if you draw median, altitude, perpendicular bisector or else you draw an altitude, perpendicular bisector, all of them are actually the same: median, angular bisector, perpendicular bisector and altitude. All four of them were same. All you have to do is just they have to give isosceles triangle. Okay. So, we will come back to the problem here. Here in this problem, ABC is an isosceles triangle. AB is equals to AC. Here he says AD is a median. You can take AD is altitude also. It becomes a median, and in isosceles triangle, median is also altitude and everything else also. Altitude means it is right angle. Angle B is equals to 35. Therefore, angle BAD. Angle BAD is equals to, if it is 90 degrees, 35 plus this angle theta should also be 90 degrees. Therefore, theta is equals to 90 minus 35 degrees, which is equals to 55 degrees. So, angle BAD is equals to 90 minus 35, which is 55 degrees. Look at the next problem. If G is the centroid of AD, BE and CF are three medians of triangle ABC with area 72, then the area of BDG he is asking you. In the previous case also we have seen the area of BDG. Triangle BDG is equals to 1/6 of area of triangle ABC. Therefore, 1/6 of 72 is 12 centimeters, 12 centimeters square. So, it is a simple one, just you have to know that it is a 1/6 of a triangle, which is equals to 12 centimeters. The area of an equilateral triangle is 9√3 meters square. The length of median is actually in equilateral triangle, all the sides mentioned, all the sides like height, median. Height means altitude, median, angular bisector and perpendicular bisector, all of them are equal. So, any of this you can find it out and you can say it is a length of median. First of all, area of an equilateral triangle is √3/4 a square. A means the side of an equilateral triangle, 9√3. Therefore, a square is equals to √3 cancel, 36. A is equals to height or the median of an equilateral triangle is √3/2 a, which is equals to √3/2 into 6. Answer is 3√3. So, length of median is 3√3. This is one way of doing it, and the other way of doing it is area is equals to h square by √3, or else we can say area of equilateral triangle is equals to median square by √3. So, area is given as 9√3 is equals to median square by √3. Median square is equals to 9√3 into 3 is 27. Median is equals to length of median is 3√3. Root of 27 is nothing but 3√3 centimeters. So, if you want to get the direct formula when between area and the median, A is equals to median square by √3. Look at the next one. The length of the diagonal BD of the parallelogram 𝗂𝗵𝗍𝗑 is 18 centimeters. If P and Q are centroids of triangle ABC and triangle ADC respectively, then what will be the length of the line segment PQ? Let us draw the parallelogram here. Parallelogram ABCD. Here are the vertices A, B, C, D. So, BD is, length of BD is 18 centimeter and P and Q are the centroids of ABC and ADC. So, P and Q is the centroid here. Let this be P, let this be Q. We all know if it is a centroid, it divides it into 2:1 ratio, which means if it is 2x, this is x. If it is 2y, this is y. Here PQ is equals to x plus y. Here BD is equals to 3x plus 3y. Therefore, 3 into x plus y. So, 3 into x plus y is given as 18, x plus y is equals to 6 centimeters. So, answer PQ is equals to 6 centimeters. So, just remember, if P and Q are centroids, it is always 1/3 of the diagonal given. So, look at one more problem here. Look at the triangle ABC. In this triangle ABC, he is asking you the area of triangle AEGF divided by area of triangle BGC. So, here BE and CF are medians, G is a centroid. Something like this is given, and they may say, in order to confuse you, they may say A is right angle, or else this is a right angle triangle. We don't care whatever the triangle it is, but always remember, if I draw three medians, these three medians divide the entire triangle into 6 equal parts. So all the areas of this triangle you see here are equal. All the areas I am taking as X. AEGF is a quadrilateral which is 2x because it consists two triangles. Now here BGC also, if you look at, this also consists two triangles, therefore that area is 2x, which is equals to 1:1 or else 1/1, or else simply is equals to 1. Here if I ask you the area of AEGF is what part of, or how many times of, or what part of area of triangle ABC? This quadrilateral area is equals to how many times or what part of triangle ABC? If you look at this quadrilateral area is actually consists two small triangles out of totally 6 triangles. Therefore, this is 1/3 of area of ABC. So AEGF, sometimes they may ask you AEGF also. So be careful here, it is actually quadrilateral, but it is composed of two triangles. Therefore, it is 2 triangles out of 6 triangles, which is equals to 1 out of 3. So far we have seen problems on medians. We have seen how median divide the triangle into different areas. So all you have to remember is this median divides the triangle into 6 equal parts, and also median, the centroid divides the median, and the point which EF here is divides the median in the different ratios. So better you remember the ratios and the areas of the triangle. So that's all for this class. Thank you.